thank you very much, Dawn. So I'm part of a team of researchers, including myself from the University of New Brunswick and my colleague Anthony Taylor from the University of New Brunswick, originally from Nova Scotia, and Loic Dornfil, he's now at the University of Laval, and two researchers at St. FX University, Andrew McDougall and Lisa Kelman, as well as James Steenberg from the Department of Natural Resources. And we have a broad range of expertise within our team. My background is more in temporal ecology and remote sensing. Loic Dornfil and Anthony Taylor both have a wide breadth of knowledge when it comes to tracking different aspects of forest health and forestry management. And Andrew and Lisa, their expertise revolves more around different types of models and computer-based models, as well as Lisa, her focus is on soil biogeochemistry. And James Steenberg also has a wealth of knowledge dealing with all of our backgrounds combined, to be honest. Yeah. Oh, next slide. I don't know if I can advance it. Yeah. Just to the background slide. Go back 2 slides if you can. Oh, there we go. I can control it now. Okay. So what are we tracking in the Acadian Phenocam network? One of the things we track is phenology. That's the timing of events in nature. It could be the timing of when the leaves change color in the fall, when the leaves emerge in the spring, or it could be the timing of when our trees start to form a new ring of cells, or when they stop forming new cells, for example. These are all examples of phenology, just the timing of seasonal events that are influenced by climate. And so we're seeing a long-term trend in temperate and boreal forests of an earlier timing of our leaf emergence, so an earlier start to our growing season. We're also seeing a later timing of our fall colors, or a later end to our growing season as well in many cases. So we're actually seeing a longer growing period. So this could be an opportunity for increased growth in our forests. However, at the same time, this could actually lead to increased stress, because if we start growing earlier, trees in many cases could run into issues with limited moisture availability later in the season, or the timing of peak growth coinciding with drier conditions. And as well, we're seeing more and more extreme weather over time, which I'm sure we're all aware of, living in a place with hurricanes and now potentially more wildfires. And these shifts in our phenology, or the timing of our growth patterns, can also coincide with greater times of risk in the year. For example, if we start growing earlier in the growing season, there's a greater chance of frost impacts to our newly forming leaf tissues. And if our leaves are still metabolically active on the trees later and later in the fall, there's a greater possibility of hurricane damage, damaging the leaves when they're still metabolically active. So it's important to understand, where does this leave us in terms of the forest health and productivity in the long term? So that's one of our main motivation, our goals is to really establish a long-term network so we can understand patterns in our leaf development and leaf cycles, as well as radial growth patterns in trees across the province. And we want to understand how our local microclimate weather patterns influence these variables. We want to set this up as a resource for people like yourselves, anyone who's interested in the status of different trees across the province over time, so they can openly and freely access this information. And we eventually want to pool our observations and calibrate predictive models so we can understand the projections for different species going into the future. How are they going to perform? There we go. There's a bit of a lag. Just want to show you a map of our network. Oh. There we go. So the Acadian Phenocam network was actually first established during the start of my PhD back in 2019, where we just had camera stations monitoring leaf life cycles. And now back in 2024, we doubled the number of sites, so we now have 24 sites on public lands across the province. And we also added some new infrastructure. And 3 of our sites are monitored in collaboration with the Mi'kmaq Forestry Initiative. So that would be our St. Croix 1 site near Lunenburg County, as well as a Maple Brook site in Cape Breton, and I'm just drawing a blank. Our Digby 1 site as well, sorry. So we have good coverage across the province from Yarmouth County to Inverness County. And at each of our sites, we have what's called a Phenocam. So that's just short for phenology camera. So it's a stationary time-lapse camera taking pictures of the canopy. And with these pictures, we can track the leaf development of each of our monitored trees in the field of view of that camera. So it's basically like using remote sensing-based techniques, except at the individual tree or canopy scale. And these are automatic systems that run continuously over time. Sorry about that. You just want to go forward one slide. Oh, there. So there's an example of a time-lapse sequence from one of our stations. It's a little video. I'm not sure if it'll work. Here's our Digby 1 camera, and just showing the leaf development over time in the video, but I'm not sure if it's going to work. Oh, that's unfortunate. Oh, that just jumped ahead a lot. Can you go back to the slide with the dendrometers? If it's possible to go back. Oh, okay. Sorry about this. Yeah, this is what I meant to show you. So this is kind of an example of what our images look like over time. And then we analyze the color patterns for each of those individual trees over time. And so our next piece of infrastructure is called a dendrometer. So this is a very small spring that presses against the stem of trees, and it can measure every 15 minutes how the trees expand and shrink. So this tells us when the trees are growing, they're forming new cells, they're expanding their current cells, or they're shrinking because they don't have enough water. So every day we kind of get a curve like this where they shrink during the day and they expand at night. And that gives us a lot of information about not only how much they grow, but when they grow, when they shrink, and how susceptible they might be to droughts. So we're currently monitoring 12 species. We have sugar maple, red maple, white birch, yellow birch, red oak, large-tooth aspen, and then we have in softwoods, red spruce, white spruce, black spruce, white pine, balsam fir, and larch as well. And so going into the drought last year. So last year was our first year of complete observations with our dendrometers. They were installed in late 2024. And so we were hoping to get a great baseline year, but unfortunately last year we had quite a severe drought. So that's also interesting to capture. And here's just a graph of one of our soil moisture sensors. So this measures what's called gravimetric, or potential soil moisture, basically how hard tree roots have to pull water out of the soil matrix. And the probe can measure from 0 to roughly 200 kilopascals. And now farmers will typically apply irrigation when you get to 30 kilopascals. But we exceeded 200 kilopascals at our site here in Digby. So that just gives you an idea of how dry it was for those trees growing there. It exceeded the measurement range of the probe, and the probe couldn't measure again until it had rained a bit and some moisture could go back into the probe. So this was really an eye-opener for me, just like how dry the conditions were. And even without even analyzing data, I could just see some early signs of yellowing in our birch leaves, for example, at some of the sites as well. And so it is categorized as a severe drought where we had less than 50% of expected precipitation values based on long-term averages. So it was classified as a severe drought. And here's also a very critical control of growth patterns. It's called vapor pressure deficit. So this is how much moisture, how much difference there is in a parcel of air between when it's saturated and the current value for air moisture. So if we have a higher vapor pressure deficit, that means there's less moisture in the air and it's harder for trees to grow. And this is actually generally more important than your soil moisture actually in influencing tree growth patterns. And so I looked at the last 30 years of vapor pressure deficit patterns across our sites. And that's the kind of more yellowy curve you see here, and I plotted the range there. And then I plotted the values just from last year. So we were much higher than the previous last 30 years in terms of like our atmospheric vapor pressure deficit. And we actually saw a peak on August 10th we had the most dry conditions in terms of our atmospheric water deficit on August 10th. And if we look at other studies across Canada, if we see a interannual variability in vapor pressure deficit, if we see just an increase of 0.1 kilopascals in vapor pressure deficit, this can correspond to 10% less growth. So when we're seeing, 0.2 or 0.3 times greater than our long-term averages, that's quite a severe reduction in growth potentially. And now looking at the data from last year. So this is a plot of our daily growth patterns that we observed from our dendrometers. So this is how much the trees are growing outwards, radial growth over time. And if we look at also the timing of peak vapor pressure deficit on August 10th, you can see in most cases that this extreme vapor pressure deficit was enough to actually interrupt our growth patterns for most of our species. Very few species actually escaped this vapor pressure deficit, these conditions, except for on the bottom here in the middle, we have red oak, which started growing much earlier than most of other trees. It has a different anatomy. It's a ring porous species, so it starts growing even for the conifers in the spring. And it managed to time its peak. The timing of peak growth for that species was much earlier than the timing of the peak drought conditions. So in some ways, that's kind of a good strategy when you have a midsummer or late summer drought for that species to start growing so much earlier. Whereas for most of our other species, we see an unusual dip in their growth patterns over time. And my colleagues with dendrometers in New Brunswick have never seen growth patterns quite like this. So we typically expect a bell-shaped curve where growth increases and reaches a peak and then it slows back down. And so that was interesting to see. And the trough, the point of interruption, the peak was generally right around the timing of our peak vapor pressure deficit. This is also, I guess it's also been seen in a Harvard study that species like red oak that time their growth earlier can kind of avoid late summer droughts by having the timing of peak growth being much earlier, often than our dry summer conditions later in the summer. So that was interesting to see. And interesting as well that we often think of our deciduous hardwood species as being drought hardy or drought resilient, but in this case, pretty much everyone was also impacted by the drought in terms of their growth patterns over time.
They made up for growth over the whole year? Complete loss.
So most species were able to resume growing. That's a good point. If you look at the vertical dashed line, that's the timing of our peak drought conditions on August 10th. And in most cases, some species did continue growing, maybe except for white birch. It could have been that they just decided to go into dormancy much earlier. But we really need more data to really compare the magnitude of growth. But that's a great point and something we're looking forward to comparing as well.
Which is the yellow birch?
Sure, yeah, sorry, I apologize for the names on here. I meant to include the common names. So yellow birch is Betula elegans, it's this bottom left.
Okay.
That's yellow birch. And your white birch there is the, on the right column and two from the bottom, Papyrifera. So you can see it did not resume growth after the peak drought conditions. But we really need more data to understand, is that typical or did they really shut down because there was too much stress? And I just wanted to show a little bit more about how our dendrometers work, as well as just an example time series. So here's an example from a larch in Lunenburg County, and we actually captured a 12-day no-growth streak, so that even at nighttime, when you usually see the trees rehydrate from the day, we didn't see that in this case for 12 days in a row for one of our larch trees. So this is kind of what your daily pattern looks like, except you would expect that you achieve a new maximum in terms of tree width at night, and in this case we didn't see that. And we actually saw an accumulating water deficit or a greater and greater shrinkage over time for this particular tree, But then eventually the tree was able to rehydrate and continue growing. By August 18th, there we see a new diameter, larger diameter. And then just looking more broadly, how all the different tree species performed. One way to do that is just to count the number of days where the trees were actually able to achieve net growth. So they had expansion beyond into a new maximum width. And if we look on the right of this plot, we can see that it was actually balsam fir had the greatest number of days with net growth, which I was really surprised because there's a lot of studies which have shown that balsam fir in general is very susceptible to drought conditions, very shallow roots and so on. And red oak also had the second most number of days with actually where they achieved net growth. But then on the left side of the plot, we see larch and also black spruce had the fewest number of days with net growth, which goes to show that they're quite susceptible. And then if we look at the timing of when the species started to grow, so the two species that had the greatest number of net growth days, your balsam fir and red oak, also had the earliest start to their growing period. So it was interesting to see. And the species with the latest start to their growing period was actually sugar maple that we observed across the network, followed by yellow birch. So there seems to be a pattern in the 2025 drought that species that started growing earlier were able to achieve more growth days. And this is also consistent with a previous study in the Harvard forest by my colleague. Oh, sorry. Just go back to the summary. We'll go back just one slide. There we go. So in summary, the 2025 drought was sufficient to actually interrupt our radial growth patterns for most species across the province. And our ring forest and conifer species, which started growing earlier, actually had almost more opportunity for growth. They had more days where they achieved net growth, surprisingly. And our diffuse forest species like birch and maple and aspen, technically their pattern of growth was suboptimal compared to the other species for the conditions of the 2025 drought. But we'll need a lot more data to really understand differences in the magnitude of growth and to capture any legacy patterns in this year. So as I mentioned, we're a long-term network. We plan to keep our network going in the long term, and so we can look back on the 2025 growing season and really understand how the trees performed versus other years. And we're also completing a soil analyses across our sites. So we've had the samples collected and they're just undergoing analysis now, but we'd like to also understand how different site conditions might have influenced the susceptibility of the trees. And in addition, going forward, we're also collaborating with other research groups in the United States and Europe to pool our observations together and to come up with improved models to predict radial growth patterns over time. And so you can stay tuned and look at our website, which just launched a few weeks ago, where you can look at different sites and see what trees are at those sites and how they're performing. We're just in the early phase, but eventually we'll be adding in this kind of data portal where you can see up-to-date information on the status of our trees being monitored. And if anyone has any comments or questions, if you don't catch me here or at my poster over there, you can also reach out to me through our website as well. And if anyone follows the Forestry Chronicle, we also just published a paper in the 100th anniversary edition as well, just outlining our network and the technologies we use. Thank you all very much.